another external memory based instruction. So here we are going to see move x at of ri comma a. So this is nothing but whatever value stored in a register will be moved to a memory location which is represented in the register. That memory location is considering the external memory location. So simple example, move x at of r2 comma a. We know that r2 will be holding the address of the data. So in this case, the address of the data, that address is nothing but a external memory address of the data. So whatever value stored in a register will be stored to memory address pointed by R2, which is external memory address. Okay, so this point you should keep in mind. X comes means that is external memory address. We are processing the data between external memory address and the CPU. Okay, so simple example as previously what we have done. So here what we are doing was whatever value stored in a, that will be stored to the memory location pointed by R2. So here a equal to 23, so 55 is the memory location pointed by R2. So R2 will a value will be transferred to this memory location. This memory location is 8-bit external memory location. So this is what happens here. Okay, so next instruction same as previous instruction, only difference is here we are going to deal with DPTR. So DPTR always provides you a 16-bit address. So data will be stored to the external memory location with 16-bit memory address. Okay, so that is pointed by DPTR. So okay, this is 16-bit memory address where the data should be stored from a register. Okay, so this is what happens as same as the previous instructions. Okay, so from this value will be moved to 4100. So 4100 is pointed from DPTR registers. Okay, that is what we are dealing here. Okay, so next instruction what we are going to see was push instruction. Okay, so push instruction always comes with direct memory location. Push direct. So we know that push is a one kind of stack operation. So what is a stack operation with push? Whenever push is happened, a stack pointer will be incremented by 1, then a data will be returned to the memory location which is given in the instruction. Okay, so from the example you will see, for example, push 55. Okay, so push 55 is nothing but this 55 memory location is having some data. Okay, so this 55 is here nothing but a address of the data. Direct means address of the data. So push 55 means this push, the data is taken from this memory location. So see that, so stack pointer, first stack pointer will be incremented by 1 and data in the 55 memory location will be pushed to the stack. Okay, so we will see that also example. Okay, so assume that stack pointer right now, stack pointer is a register which is holding the address of the stack. Okay, so stack pointer is one register which is holding the address of the stack, so that you can't initialize it right now. So right now assuming that stack pointer equal to 08. Okay, so this is what stack pointer right now holding, that means it is pointing the stack memory location 0.08. Okay, so 55 is nothing but a memory location of the data. So in this 55 memory location we are having a data 23. Okay, so what will happen first? So initial condition will be stack pointer is pointing a stack memory location of 08. Whenever this push instruction is executed, what will happen? Stack pointer will be incremented by 1. So stack pointer equal to stack pointer plus 1. So stack pointer becomes 09. Now the stack pointer will be pointing the memory location 09. Okay, so one after push, after that what will happen? The value from this memory location will be pushed to this memory location, that means the memory location pointed by stack pointer. Okay, so this value, that means value from this memory location, that means 23, will be pushed to or stored to the memory location pointed by stack pointer. Okay, I am repeating again what is happening here. So push is nothing but a stack operation. Push means what will happen whenever a push operation is called, stack pointer will be incremented by 1. After that, whatever data that will be pushed to that memory location which is pointed by stack pointer. Okay, so from this instruction you can see that push of 55. Okay, so in this instruction this 55 is nothing but a internal memory location which is having the data. Okay, so you need to push a data to the stack pointer, right? That data is stored in this memory location. So push 55 means a data from this memory location will be pushed. Okay, so right now assuming that 55 is having a value called 23, so this data will be pushed. Where it will be pushed? Whenever this instruction is called, first thing was stack pointer will be incremented by 1. Okay, suppose assuming that stack pointer equal to 08, when this instruction is called, stack pointer becomes 09. Okay, so stack pointer will be incremented by 1. Okay, after that the value from this memory location, that means 23, will be moved to the stack where the memory location pointed by stack pointer. Okay, so stack pointer right now is holding the stack memory location of 09. In the 09 this 23 will be pushed. Okay, so this is the main operation of push. So same as another instruction called pop. So pop instruction is another stack operation. This pop instruction is used to retrieve the data from the stack. Okay, we are going to retrieve or we are going to read the data from the stack. In push we are going to write or load the data into the stacks. Okay, in pop we are going to read the data from the stack. Okay, so here also pop 55, what will happen? So whenever pop 55 comes means, first this 55 is nothing but a memory address which is going to be used for storing the data from the stack. Okay, so from the example we will see, assume that stack pointer equal to 09. Okay, so 55 is right now having 53 as a data. Okay, so pop instruction, what I told, we are going to read the data from the stack and then we are going to store it in the internal memory location. That is the pop operation. Okay, so now what happens? Right now stack pointer is pointing 09. So the data from that stack, okay, 09 stack, that data will be taken. Okay, that will be stored to memory location 55. After storing this data into that memory location, stack pointer will be decremented by 1. Okay, so stack pointer will be decremented by 1. So after this execution of the instruction, how it will looks now, stack pointer right now will be pointing 08 because it is decremented by 1, and then 55 memory location is loaded with this data 23. Okay, so this will be loaded to 55 memory location. This 53 will go. Okay, so this 23 will be loaded to 55 memory location. That is what happening here. This has been loaded here and then stack pointer is decremented by 1. Okay, so you should be remembering that whenever push is happening, increment the stack pointer, then load the data from the memory location to the stack. Okay, whenever pop is happening, read the data from the stack, then decrement the stack pointer. So the reader data from the stack should be stored to some internal memory location. That some internal memory location is here 55. Okay, understood? So keep it in mind. So next instruction is XCH A of Rn. This is nothing but exchange register to the accumulator. That means we are going to exchange two registers. Example, XCH A comma R2. So data between A register, R2 register will be exchanged. That means what? For example, A equal to 36. Okay, R2 equal to 53. Suppose this is the initial condition. After executing the instruction, what will happen? Whatever value in R2 will be moved to A and whatever value in A will be moved to R2. Okay, so exchange will be happening. Okay, so this is what happens with respect to of XCH instruction. Okay, next instruction is XCH A comma direct. Same, this is also we are going to exchange the data between the accumulator and the direct byte. Okay, previously the exchange has been happened between two register. Now the exchange has been happening between A register and the direct memory location address. Okay, same XCH A comma 55. This 55 is holding the address of the, this 55 is holding the data. Okay, this is considered as a memory location. Okay, same as XCH A comma out of RI, which is nothing but previously we have seen that, right? A comma out of RI will exchange the data between A register and the data in the memory location pointed by R2. Okay, so that is what happens with respect to XCH. Okay, so next XCHD. Okay, previously we have seen XCH. Here we are going to see XCHD. A comma out of RI. Nothing but here the exchange will be happening only between the lower nibble data of the registers. Okay, simple example. Assume A equal to 36. Okay, R2 is holding the value 55. So out of R2 means what? Whatever data stored in R2 will be considered as a memory location for the data. Okay, so then the CPU will go to the memory location. Now 55 is having 78. So whenever this instruction XCHD is called now, so what will happen? This 8 and this 6. Okay, so 8 from 55 memory location and A register 6, that means lower nibble. Okay, 6 is the lower nibble and 8 is the lower nibble in these two cases. Okay, so these two only will be getting exchanged. Okay, so example, this is what happens after the execution of the instruction. A will be having 38 and 55 memory location will be having 76. In this case R2 will not get affected because R2 is not having data. R2 is having a memory location of the data, so we doesn't deal exchange between R2. Okay, so R2 just points the memory location where the data is. From that memory location we are going to do the exchange. Okay,